Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for advanced function students who are reviewing for the exam. I handed out a review page with question number 6. This is the question. And in my original PDF of the solutions, I'd made a tiny error that didn't affect overall how you're supposed to solve the question, but does actually impact the final answer slightly. So I'm going to make this video to correct that, and also just in case anyone wanted to see exactly how do you do this question. So here's the question. So I'm told information about x. What I'm told is that cosecant x is equal to 37 over 35, and x is in this quadrant, and let me just identify that. That's quadrant 1. So all of them are positive. Sine, cosine, and tangent, and all the reciprocals, they're all positive in quadrant 1. So that's what I know about x. I know cosecant x is this ratio, and I know it's in quadrant 1. Here's what I know about y. Cosine y is this ratio, and it's in this quadrant, which is quadrant 3. And in case you're wondering, this is where I made the mistake in my original review package. I assigned it a different quadrant, strangely, which means that I got some of my polarities wrong. So this is in quadrant 3, between pi and 3 pi over 2. And in that quadrant, hold on, let me just double check. Quadrant 3, right, only tan is positive. So what do I need to do? So that's the information I have. So let's look at what I'm supposed to do in this question. So in A, I'm supposed to find the value of cotangent x. So that means I want to find tan x. Well, I have cosecant x, which means I sort of have sine x, and I want to find tan x. So I'm going to do that by using what I know about those trig ratios fundamentally, is because I know sine x, I know that if we call this x, I know that the opposite would be 35, and the adjacent would be 37. And I can use that information by Pythagorean theorem to find this, and then I can find tan or anything else. So I'm just going to note that. And then over here, when I'm trying to find this one, to find cosine x minus y, well, I know I'm going to use the identity, where I will rewrite this as cosine x cosine y plus sine x sine y. So in order to complete this identity, I need to know cosine x. Well, here I have sine x and tan x. I'm also going to need cosine x. So again, by doing this Pythagorean theorem, looking at the ratios, I'll be able to find that. I need cosine y, well, I have that. I need sine x, that one's going to be okay. And I need sine y. So again, just like I'm going to do for x, in order to find what sine y is, I'm going to need to take this ratio and figure out what that would be in terms of the trig, the Pythagorean theorem sides of the triangle. Anyway, let's just go look at what I'm talking about instead of just talking about it. So again, the logic I'm using, the whole point of what I just talked about was to say that what you know is I know that sine x is the reciprocal of this. So sine x is 35 over 37. And what we just talked about on this page is that I'm going to need to also know tan x and cos x. So what that means is I'm going to have to take this information about angle x and find both cos x and tan x. And so the way we do that is we go right back to some very fundamental ideas about trig, which is that in a right angle triangle, if we define one of the angles to be x, then this information tells me that the length of the opposite side compared to the hypotenuse would be 35 compared to 37. And now I can use the Pythagorean theorem to calculate the length of this missing side, which is the adjacent side. So 37 squared, c squared equals a squared minus b squared, so adjacent squared. And then if I calculate and do that math, oops, I don't remember my answer, so I'll just actually calculate. This is exciting video stuff. Yes. So I find that the adjacent side is exactly 12 units. If it was a decimal, I would write it as a square root. Like I wouldn't use the actual decimal, I would use a root sign. So I know that the adjacent side is 12. And if you remember, angle X is in the first quadrant, so all of the trig ratios are going to be positive. So let's figure out what they would be. So we already knew that sine X was 35 over 37, and now I know that cosine X is 12 over 37, and I know that tan X is opposite over adjacent, 35 over 12. And they're all positive because of the quadrant. So that's me breaking down this information into everything I might possibly need to know about angle X. And now let's do the same thing for angle Y. Here's what we know about angle Y. We know that it is the ratio -7 over 25. It's the cosine. And we know that it's in quadrant 3, where only tan is positive. So I'm just going to make a little reminder note here. So again, I'm going to fundamentally go back to the basics of trigonometry, which is that in a right angle triangle, if this is y, the length of the adjacent side compared to the hypotenuse would be 7 over 25, and therefore I can use the Pythagorean theorem to calculate the length of that missing side. So 25 squared equals 7 squared, pen went crazy, plus the opposite side squared. So if I do that math, I discover, hold on, here, that the length of the opposite side is 24. So let me put that on my diagram. So now, not only do I know what cosine y is, I can now tell you that sine y is opposite over hypotenuse, and it's going to be negative because of the quadrant that I'm in. And I don't think I need it for any reason, but let's write it down anyway. Tan y is opposite over adjacent, which is 24 over 7. So now I have cosine, sine, and tan for y, and now I can answer both of these questions pretty quickly. So we know that cotangent x is equal to the inverse of tan x, and we know that tan x is, let me go find it, tan x is 35 over 12, and therefore cotangent x is 12 over 35. Done. So to find cosine of x minus y, we'll first use the identity to rewrite that as cos x cos y plus sine x sine y, and then each one of these, so cos x, I know what that is, I know what cos y is, I know sine x, and I know sine y. So let's go find them. Cosine x was 12 over 37. Oops. 12 over 37. Cosine y was -7 over 25. Sine x was 35 over 37. And sine y was -24 over 25. And so the value of cosine x is this value, and so on. So remember, at no point did I find what x was, but I know what cosine x is. And now I just have to do this algebra and make sure I'm getting, common denominators and all that. So 12 times -7 is -84. And then in the denominator, I have 37 times 25. I know there's nothing more exciting than a video where someone types stuff into a calculator. I didn't do that right, especially when they type it in wrong. So that's 925 plus, and then I'm going to have -24 times 35, so that's -840 over 37 times 25. So I already have a common denominator, so -84 minus 840 is -924, and that's not going to reduce, so that's the exact value. Okay, I hope that's helpful. Sorry about the original error, but I hope this video helped.